Hi, this is Coach Chuck of the National Free Flight Society Youth Development Program. In this short video, Coach Brian makes a demonstration of building a propeller for a Science Olympiad airplane. This is excerpted from a 1-hour live seminar that was done in October of 2021, and the link to the entire seminar is in the comments below. With that, we'll let Brian get started.
All right, building your own propeller. So the heart of the project, and I think Chuck would agree with me on this, is the propeller and matching the rubber motor to the propeller. And he and I both test, and I'm sure other teams do this too, maybe dozens of different propeller variations, which go along with each dozens of different rubber motor densities and lengths every season. So real quickly, I'm going to show a little bit about bending a wire shaft. So I happen to know that this hook that I have my finger on right here, which I think you can see, uses about 8/16 or about a little more than a half an inch of wire. So I have about a half of an inch of wire gripped in the pliers here going in that direction. I'm going to put a shallow angle, and then I'm going to check it on the shallow angle bend, and I'm going to check it against my diagram. And it's pretty close. It's rare that I bend one perfect every time. And then I'm going to grip the wire in the jaws at a point where the jaws are about 1/8 of an inch thick, wide. And then I'm going to put approximately a 90-degree bend in the hook. See if you can see that. Are we spotlighted on me on the workbench? I think so. Good.
Yeah.
Okay. So now we have the first two bends, and you can hold the bend up again to the diagram, and you can see that looks pretty good. So this is going to make a hook that's about 3/16 of an inch deep, and it's a diamond-shaped hook, which is not the best hook, but it's a pretty good one. So I'll grab the hook and the pliers again, and I'm going to take 2 steps to make this bend because it's an acute angle, and I don't want to snap the wire. So now I have 3 of the 4 bends made. And the final bend, I will use a little tiny wooden block and just fold the tip back just a little bit. So there's a hook, diamond-shaped hook. The reverse S hook is probably the best hook. You'd need to use plastic O-rings instead of hard rubber O-rings if you're going to use that, but it does center the rubber really well on the hook. So in propeller making, the first thing to do is decide on your blade shape. So there's a lot of different blade shapes you could use. I'm going to show you a flaring blade shape where all the blade area is on one side of the spar. So this is actually just a tracing of the Ikera propeller, the area that's on one side of the spar. And you can see I trimmed it off just a little bit. So it's not a bad place to start. So I'm going to trace that onto the wood I'm going to use. And the wood I'm going to use is 1/32 sheet, 8 pounds per cubic foot, which would give a reasonable amount of strength and also stiffness and still be quite lightweight. So 8 pounds per cubic foot, you can do the calculation to figure out what a sheet of wood would weigh in order to give you that density. If you cut the propeller blades out of 8 pound per cubic foot, 1/32 of an inch thick wood, you'll end up with blades that are about 0.32 to 0.34 grams each. So the next step is, and I'm not going to show this, but you would soak both blades in water. Now other people will do this a little different way. Maybe they'll use alcohol, but I'll soak them in water for about 20 minutes. So really dunk them underneath the water, let them sit for 20 minutes. After 20 minutes, I pull them out, put them on a paper towel, and blot them dry. Then I will attach the blades to a form, and this is a propeller pitch form. You can see it's twisted. In this case, it's twisted to give you a helical pitch distribution. So there was a question in the chat about what is pitch, and you'll be able to see it better when I take the blade off the form. Other forms you can use can be something as simple as a can. This is a 4-inch hot chocolate container, 4-inch diameter hot chocolate container. And if you angle the blade on the hot chocolate container and you form it, I'll describe that in just a little bit, you end up with a blade that has pretty good pitch distribution, not quite helical. So the angle you'd use on a 4-inch can for the propellers this year would be approximately 20 degrees. And you can see what I mean by angle. I've got lines drawn on here and I've got degree markers, 20, 25, 17. 20 degrees would be about right this year to give you a pretty even pitch distribution. So putting the propeller on the form, you'll be able to see how that happens as I remove it from the form. So the two propeller blades are underneath this gauze bandage. It's just simple rolled gauze, not the adhesive gauze, just plain gauze. So when the blades were wet, I wrapped this gauze around the blades very tight to twist them into the shape of the form. Now that and then I put them in a small toaster oven, bake them for 20 minutes. You can also microwave them. It goes a little quicker. So removing them from the form, I did have a little bit of silk span that I could put between the blades. It makes it easier to get them apart. Sometimes they'll stick a little and you have to slip the dull side of a razor blade into pull them and separate them. So you can see there's a twisted shape to the blade now. So the angle of that twist is what we call the pitch once it's set on the spar of the propeller. So the angle that Chuck was referring to, 40 degrees at 3-inch radius, is about what I'm going to do with this jig. So this jig, you can see, is holding the propeller spar, which is 1/16 inch basswood, 6 inches long, and it's been slightly tapered by just sanding it carefully to about 40 thousandths or so. You can also see that how the hook is mounted into the spar. It's a 20 thousandths wire shaft. So I drilled with a wire drill, an 18 thousandths hole wire drill, right? If you don't have these, it's kind of a good idea to get them. Wire drill set. So the angle of this jig is about 38 degrees at about a 3-inch radius. So the 3-inch radius is from the center of the prop shaft to where the jig is. Attaching the blades to the propeller spar is just a matter of very gently lining the edge of the blade up with the spar and touching the blade to the angle of the jig. And then I'm actually not going to do this because we're trying to move quickly. And then I'm gathering a drop of glue with a pin applicator, 2 pins poked in a stick, and I'll pick a drop of glue up from a piece of wax paper. And then I'm going to glue just the contact point near the root of the blade to the spar. And I'm going to hold it against the angled surface here. So once that dries, I'll take a small piece of tape and I'll tape the blade onto this jig. And then I can pick the whole thing up and flip it over, and I can get at the spar from the other side, put one more drop of glue on it. I'll probably just put 1 drop of glue at the root, 1 drop of glue near the tip of the spar, and I'll attach both blades. And then I'll put the blades on a pitch testing device to see if it turned out the way I thought it would. If it's not glued too securely, you can still crack the joints a little and you can correct it. So this is one blade, and then you can see this part of the jig is pinned on, so I can remove the pins, remove the blade, or remove the entire propeller, flip everything around, and then I can do the other blade. I didn't show this very carefully, but you can see that this propeller jig is using a Harlan bearing to hold the propeller shaft still while all of this is being done. You can also make a jig that just holds the propeller shaft with rubber bands. And actually, this is a slightly different jig. it holds the propeller shaft pointing down. And you can see that the propeller shaft is just going to be held in a little grooved piece of basswood with a couple of rubber bands. This is a little trickier to use because things are moving around on you. Let's see, did I skip over anything? Yes, pitch diameter ratio. So the pitch that we were talking about, roughly 40 degrees at about 3-inch radius, will produce a pitch of around 15.8 inches. Sorry not to use metric, but that's how my brain works at this point. I'm working on that. So we often refer to the pitch diameter ratio. So the diameter of this propeller, 24 centimeters or 9.44 inches. Pitch diameter ratios that are usually worth testing are between 1.4 and 2.0. So one more thing about pitch, sorry. You can think of pitch, this twist, when we're talking about inches. You can see the twist of the blade. If you think of this as the angle of the thread of a screw, and the screw is turning into something solid. So because of this angle of the blade, the propeller is going to move forward if it were a screw moving through something solid. So it will move forward through that solid thing a certain distance based upon this angle. So that's what a pitch distance means. So the 40-degree angle Chuck was talking about at a 3-inch radius will move the propeller forward as if it was going through something solid, roughly 16 inches. So pitch diameter ratios of 1.4. 1.4 would mean roughly 13-inch pitch, 1.4 times 9.44, and up to 2.0 pitch diameter ratio. So a diameter of 9.44 would give you almost a 19-inch pitch. And we will try all of those pitches, probably in 1 to 2-inch increments, which is 1 to 2 degree increments, all with various different rubber thickness, rubber densities. So that's basic propeller construction. It's really not that hard. I would encourage everyone to try it.
All right. I should point out that on the NIFIS links on our YouTube channel, you will find about an hour-long video that I did on making the entire prop. It'll go along the lines of what Brian just showed you. But if you want to go reference that, it's on the NIFIS YouTube channel, which you can get to from freeflight.org.